Okay, so I have this problem. A 47 microfarad capacitor is connected in series with a 39K resistor across a 24 volt DC. So it's something like this. There's a resistor, there's a capacitor, and we want to see the transient effect. So I will add a switch. So this is the 47 microfarad capacitor, and this is the 39K resistor, and this is the 24 volts voltage source. So we need to find the circuit time constant. Circuit time constant, this is R, let's say this is C, and let's say this is E. So circuit time constant is RC. So that is RC, and this case R is 39. We have to convert it into ohms. So that, and then 39 kilo ohms. So this is 47 times 10 to the power minus 6. This needs to be converted to farad. So this is becoming, this will be in second. So this is becoming 1.833 second. So that is RC, which is the time constant. Then it says the values of for initial current and final charging current. So initial current is when the switch is closed, that's T is equal to 0 when the process begins, the charging of the capacitor begins. Initially, we know for the capacitor initially acts as a short circuit because it the voltage across it doesn't change. Initially, the voltage was 0 and it doesn't change instantaneously. So what happens is when the switch is closed, the capacitor voltage across voltage still remains 0. It can be shown mathematically as well, but I will just talk about it physically here. So the voltage across the capacitor is 0. That means the current is, so basically the capacitor is short circuited initially. So the initial current will be I will be the initial current, let's say I0, that would be just E over R. So only the voltage source and the resistance will decide the current, which is 24 volts, and this is 39 times 10 to the power 3. So that is, sorry, 10 to the power 3, and that one gives us uh, 0.000615 amps, or we can say 615 microamps. So very small current initially. And then final current is, of course, when the capacitor becomes open circuit. So capacitor is fully charged and that's an open circuit. The final current is, of course, 0. The initial current, let's say call it I final, that will be 0. That's always for a DC circuit. When the capacitor is fully charged, it doesn't allow any more current to flow through it. So the current becomes 0. But the initial current is decided by the connecting resistance and the applied voltage source, the connecting series resistance and the applied voltage source. And the time taken for the capacitor to become fully charged, that is actually we think of 5 time constant. So that would be 5 times. So this is time constant is often written as tau, Greek letter tau. So for the capacitor to fully charge, it takes 5 tau, 5 times tau. So that will be 5 times 1.833 seconds, which is 9.165 seconds. So that is the time it takes for the capacitor to fully